Hello, everyone. Welcome to Microsoft Reactor London. We are so excited to have you all back in person with us. So today we have the A Bit of AI mini conference live from the Reactor. Of course, we've been having these events virtually from the past 2 years, but we are so excited to be doing them in person. For all our upcoming events, please do follow our Meetup group, which is called Microsoft Reactor London. You can find it on Meetup. And with that, I'm now going to hand over to Henk, who will introduce A Bit of AI.
Hi everyone, and welcome to the A Bit of AI show. Today, for the first time, actually live with an audience, something we wanted to start doing 2 years ago. So now we finally got to do it. So thank you all for joining, and thank you all for joining online as usual. So today we have a mini conference. Normally the show is 30 minutes, but today we have around 2 hours content and pizza. So we will start off with a talk about MLflow from Terry. Then we will move to Gavi after lunch, after dinner, pizza. For us it is dinner. And then we will have Richard, who is going to talk about algorithms. And finally, we will close off with a small panel about life in AI, because the A Bit of AI show is all about careers in AI. What do people do actually during the day when they say we work in AI? So that is what we're going to find out later in the panel, and also about how they learn, how they keep up with all those new things. So please welcome now Terry to the stage, or in the frame.
Good evening, or good morning, depending on where you're tuning in from. Thank you very much for having me.
Welcome, hi, thank you so much for joining us. You have been a guest virtually.
Yeah, on the first ever show. So I'm pleased to be here on the first ever live show. I think I get a special badge, a t-shirt, I don't know, we'll sort it out later.
We'll talk about that later, yeah. But you were on the first show where we actually thought it was good to have 3 guests in 20 minutes.
Good.
Yeah, so you had 10 minutes, so we gave you a little bit of extra airtime today.
Thank you.
So we always do something with the A Bit of AI show to get to know our speakers a little bit more. So we kind of already asked you about what your first computer was, what your first programming language was. But I want to know, what was the first thing you actually programmed?
The first thing I actually programmed, I feel awful saying it, but I think the first thing I ever programmed was probably the worst database ever built in Microsoft Access. That was modeled around trying to model lost payments for a debt collection agency. It's awful. And I look back at it now, it was probably the worst thing ever written, but you have to start somewhere.
Excellent. I did the same thing too. I tried to make a help desk system in ASP and Access as the backbone. So I hope nobody is using that anymore.
Someone is. Someone.
Oh, there must be somewhere, of course. So I would say we will talk later in the panel a little bit more about learning about the history of AI and so on. So now kick it off with your presentation about MLflow.
Thank you. All right, thank you everybody for being here. I don't know how many of you, this is your first in-person user group, and it's great to see you all. So today we've got about 20 minutes to kind of run you through an overview of MLflow. And of interest for people here in the audience, who's using MLflow already today? Perfect, you're the captive audience. Everyone at home, there's only one hand, so everyone else will get a good general intro. So, Terry McCann. I run a consultancy in the UK called Advancing Analytics, and we specialize in basically anything data engineering and AI. You still might not be able to see my screen. Hank's going to press a special button. Ta-da! If you like this kind of content, I recommend you check out our YouTube, because I've got a load of additional bits and pieces like that. I'm a Microsoft MVP for AI, which basically means I just spend too much time at events like this and probably not enough time actually doing any real work. But there's someone else will probably tell you about that. Right, so what is MLflow? So given that we're all kind of new to this here, MLflow is an open source kind of model management application. So it has a kind of history in, it originally started around, gosh, it must be about 5 years ago, as a project by somebody at MIT. And at that time it was called ModelDB, and it was focused around how you productionize a machine learning model written in MLlib at that point. And since then, it's been picked up by Databricks and picked up by the open source community, and it's been scaled out to this environment that enables you to manage your machine learning models at scale. The key thing to think about here, though, is it is open source, so you can pretty much run it anywhere on any kit that you have. And there are a couple of different options, and we'll talk through them. We'll look a little bit at like what are some of the best ways to get working with it. So generally, when you look at MLflow, there are two main ways that you can get started. You've either got the open sourced version, or you've got what's called like a managed version of MLflow. And the managed version is built inside of Databricks. So Databricks, if you're not aware, they're the main, the main company really powering Apache Spark, founded by a lot of the original founders of Apache Spark as well. Now, when you look at MLflow from an open source perspective compared to a managed, there are subtle differences. Over time, you kind of get feature parity, but generally, one is slightly ahead in some areas. It's never the case that the managed version is completely behind. Generally, there's a little bit of to and fro. Thank you. I need 2 mics. Oh, wait, I've only got one again. So comparing the differences, right? What does MLflow actually give you? So MLflow gives you an experimentation tracking. So imagine you're training a machine learning model, right? You're going through, you've got your data all kind of curated into the way that you like it. However, what you're doing is you're constantly iterating. You're trying one model to see how that works, and then maybe you're saying, actually, you know, that's not giving me the accuracy that I want. I'm going to throw that one away. I'm going to try something else. Still not quite right. I try something else, and I try something else. And maybe this is like over a week, right? And then you get to the end of the week, and you're like, you know, actually the first thing I tried was still the best. How do I get back there? I can't actually remember what I was doing. Well, what tracking gives you the ability to do is to flow that through, right? And kind of monitor it and see what changes you're making and what are those improvements. It also gives you the ability to kind of monitor what everyone else in your team is doing as they're working potentially towards the same problem. You get projects. And so in the open source project, that gives you the ability, along with the model aspect, to take your MLflow model and actually get that deployed somewhere. So that might be back into something like Azure Machine Learning or into something like AWS SageMaker, depending on what your platform is, but giving you the ability to very easily containerize a machine learning model and get that running as a kind of real-time service. Now, there's something very similar inside Databricks, and this is where we start seeing the differences appearing. So Databricks offers its own kind of standalone model deployment, which we'll have a look at and we'll have a quick demo of in a moment, which doesn't appear anywhere in the open source version and is kind of just like a Databricks only add-on. And then the final part that you really get from MLflow is a model registry. And this is what really gives it a lot of power, which is how when I'm training a model and I'm going through and I'm doing all these kind of iterative experimentation phases with my machine learning models, what do I want to do with the model that I'm actually creating? So when you train a model, right, you'll take your data, you'll take a generic algorithm, you'll put the two together, and then out pops your lovely model, right? But what do you do with that? You don't want to retrain a model every time and produce a new model. You want to persist that somewhere. Now, historically, what that persistence would look like is you'd write it down to a file system or maybe back down to a lake. And you'd have to always know where that model lived in order to bring that back in. But what MLflow does is it gives you the ability to say, actually, I want to publish this model to MLflow. And then if I'm looking at a batch machine learning scoring process, I just go and read it from my model registry. Or if I'm doing a real-time service where it's behind an API, all I do is I say, well, when that API starts, go and read the current version and bring that back in. So that service is all spun up and ready to start working with. Now, when it comes to Databricks, we have some of these things, but we don't have everything. So we have experimentation tracking. So we can track our models as we're training them, as they're going through. And we can get this all without having to essentially stand up anything else beyond just a Databricks workspace. We don't have projects. We do, however, still have models as well, and we do have the model registry. So there are things that we can do here, but as mentioned, the actual kind of core provision of standing up a model or a real-time API does exist in Databricks, but it's not quite the best service, but we'll have a look at why that is. So MLflow has a ton of built-in integrations. So you might be used to serializing a machine learning model, right? You train a model, and then at the end, you've got this piece of code, right, that is your actual model. Historically, what we would do is we would use something like Pickle to serialize that model back down to bytecode so that we could use it as another process. But the difficulty with that, right, is that works for a lot of things, but there are very bespoke reasons for different types of models. You might be training a deep learning model, something like Keras or TensorFlow up there, where you need to actually store the model architecture and then all of the weights as well. And storing that as a pickle file is doable, but it's very large and it can be very cumbersome to work with. And especially when you're working in other formats such as R, or even in such a format such as Onyx, there's a lot of kind of different ways that you'd want to work. And what MLflow tries to do is simplify that by giving you a standard place to deploy to, and then a standard place to read from. So a quick Google before this. We are currently at version 1.24. So this was released back in February. And so one of the interesting things about MLflow is maybe about 8-9 months ago, it actually made a major release at version 1. And since then, we've seen a ton of incremental improvements. And you can see here, right, if you look at any of this stuff, you get a huge amount of improvements of each and every iteration. And so here you can see a couple of bits around improvements to the UI, improvements to model printing, some additional bits and pieces, some integration with SageMaker, and then there's a ton of additional bits and pieces in here. So with each release, you get a load of additional features. The thing to be aware of, though, with the open source version versus the Databricks version is depending on where you are and which Databricks runtime you're using, typically you'll find the open source version is a few iterations ahead. So if there's things in here that you really want to get started with, you might not have those available to you. So let's think about, what is a typical flow? A typical flow might look like this. I'm joined by my mustachy friend. And my mustachy friend is training a churn model. And with this churn model, he's going through, he's building it out, and the first thing he does is version control everything, right? But during that training process, he's actually writing that model back into MLflow. And from there, we have a couple of options. If this is a batch model, then we've got a few different things that we could look to pull this into. Maybe we're reading it back into Databricks, and we're just looking at a huge amount of our data, and then we're scoring each record that we see. Or maybe we're putting it behind a real-time API where it's sitting behind some kind of A/B system live on our website. We can do both of those. This example looks at the kind of batch one, right? And so then it's orchestrated with Data Factory. So Data Factory might just go and say, right, well, I want you to call this notebook inside Databricks, or it could be inside Azure Machine Learning. You've got a lot of flexibility, ultimately, to run our model on a daily basis. And the benefit of having this means that basically when we are kind of here, we have a complete separation between training and scoring. So when we look at retraining our model over time, we retrain our model and push that up into MLflow. From a scoring perspective, it doesn't really care because it's always going back and reading that production model. And that can be really powerful in terms of simplifying your kind of route to production and also your management process. So you can install the open source version just by pip installing it. You can do that on your local machine. You can do that in a number of different ways. If you want to run the open source version, our approach and our recommendation is always to run that inside a container, inside something like Kubernetes. Because that way you can create a nice centralized service that you write things to. The benefits of running MLflow on your laptop are slim, aside from kind of tracking your own things. If you're a single developer, that might be really useful for you. But generally, if you're working in a team, you want a centralized deployment. And then when you run it, you can just run it like this. But we'll have a look at doing that. So let's have a look at a couple of different things. So we're going to do a demo for a little bit of the time we've got left. We'll look at managed ML flow. We'll look at experimentation tracking. We'll look at deployments. But also we'll take a quick look first at the open source version. Right. So hopefully when the screen kicks back in, as long as I've not broken it. Have I broken it, Henk? Ta-da! Fixed it. So this is the MLflow website, right? And you can see that same thing that we were looking at. So here, if you go and have a look, it's actually a very good website for there's a great deal of documentation in here. But it'll take you through a lot of those things that we were looking at in terms of tracking, projects, models, and the registry. To get this kind of running locally, as mentioned, all you really need to do is you need to pip install it. And then once it's pip installed, you can run something a little bit like this, right? You can just say MLflow server, and then that will start a local instance. And what you can see is it's running on my local host, so 127.0.0 on port 5000. And now if we go along and we actually open that, what you can see is an MLflow, right? This is the very basic vanilla view of what you will see. And it's designed around giving you this option right up here to kind of track your experiments and then also track your models. If you try and run this locally, it will run like this. But what you'll quickly find is you try and do anything and it's going to start throwing really angry errors at you. And that's because it doesn't have anything that it needs to underpin itself. So if you think about experimentation tracking, you want to track a couple of things. You want to track all your key metrics, like what are the loss values that your model is training towards. But you'll also want to track what are kind of the actual physical model you're training, and maybe some of the associated artifacts, your data, your label-encoded attributes, possibly some metadata about what you're doing, and the physical model itself. So you always need two different storage accounts. You need some kind of database for that data to track to, and you need a kind of like HDFS compliant subsystem, like Azure Data Lake Store or an Amazon S3 bucket. You've got some flexibility, but without those, it's going to say stuff like, I don't know what you're trying to do. I've got no idea. Other alternative, right, is to look at something like using Databricks. So this is Databricks. Databricks is a fantastic environment for training Spark models, but also for training any model, really. And I've got a super basic example here. And what this basic example does is it looks to train a bike model, so a bike regression model. I think it's based on something like the San Francisco data about bike rentals. And what we're looking to do is create a model which predicts how many rentals will be, how many rentals we expect per day, right? So what we've got in here, again, if no one's ever seen this before, Databricks is just basically like a notebook environment. It looks very much like Jupyter. You've got kind of textual cells as well as code cells. And so I've run this already. So we'll just kind of talk through high level what we're trying to do. So what we're doing is we're importing a load of different packages, and these packages are all using SparkML. So Spark is a distributed machine learning framework as well as a distributed engineering framework. And so with that, essentially, you've got a cluster of different machines, and each one of those machines are working together to train your model. For MLflow, you don't need Spark. You can use anything, right, like we said, such as Torch, such as scikit-learn, XGBoost, whatever it is that you are working with. But what we'll do, right, is we'll take some data, we'll bring that data in, we'll read that data in, and we'll start bringing in MLflow. So the first thing that you can do is you can just say something as simple as mlflow.startrun, and then everything after that will begin tracking if you start pushing stuff to it. So we could say something like this, right? I want to set a seed, and I want to do some train and test splitting, because I'm doing a supervised model here. And I'm using a gradient boosted tree regressor. And so what I'm going to start doing is, first of all, is I'm going to set the tree depth, and I'm going to set the number of trees. And then I'm going to log these out into MLflow so that I can see what was the reason why I got the model that I did. And I might be looking at this in 6 months' time, right? And I can see, oh, it was because I set a tree depth at 15, and I set the number of trees at 10. I'm then going to train my model. So in Spark ML, it uses a pipelining approach. So you set up a number of transformations, run that all through a pipeline, and then that pipeline becomes your model. The assumption there being you kind of have dirty data coming in one end and your lovely clean model at the other end, so that when you've got dirty data in reality, you've got nice good predictions at the end. And then you might produce your predictions, okay? And then the other thing that you might do is then say, well, actually, I want to log this, right? I want to log the metrics that are coming out of the back of this. And by logging those metrics, we can see over time what is happening. So what I'm going to do is I'm just going to clear states here, and I'm going to run all. And this will start running. And one of the things you'll see is you've got this little button at the top here, which says Use MLflow Tracking API. And if I click into this, what you'll start seeing is you'll start seeing some of these values appearing. So you'll see for this last run that I had, if we zoom in, I had 10 trees, and I had a tree depth of 15. And then I also had a couple of values coming out the back. So I had an R squared of 0.87, and I had an RMSE of 63, basically 64. So I had a root mean squared error of 64. So what that basically means, right, is on any given day, I am wrong by about 64 bike rentals. I don't know how many bikes fit in the back of a van, but that's probably more than a van's worth of bikes. It's probably not a very good model. We want that number to be a lot lower, right? So this is where we would iterate, we would try different things, and we would see what we could do. And then the next kind of logical step that you would go through is to register that model. And so the way that you would do that is you could just say mlflow.log model, or you could use something like mlflow's auto-logging. So one of the things that we see with constant iterations is improvements around auto-logging, which gives us the ability to log a lot of our loss metrics and the inputs to our parameters in a very simple way. Once a model is logged, what you're able to do is to actually see that, if I expand this down here, down in our models. And what that gives us is the ability to start doing things like model versioning. So you've got a staged model and a production model. And with each of these, you can choose between which version it is that you're using, as well as any of the historic versions that you've persisted before. And so what you can see here, right, is let's take this one here called Delete Me. All of the best models are called Delete Me, right? And if I click into Delete Me, I can see a little bit about the history of what's happened here. So I could look at the description, and currently there's no description, but I would say, actually, right, this is a great model. And a couple of exclamation marks, right, just to show how great it is. And I can see that. And now I've got this here, and it's here that I can actually start saying, well, what I want to do with this model is I want to start working with it in a couple of different ways. I might want to persist this into production because I'm really happy with it. So if we have a look into this Delete Me again, go back to our registered models, what you can see currently is there's one version. So I've got one version of my model here. As I went retraining, I'd see each and every model, and some of them might be better and some might be worse. But what I might also do is decide that I want to spin this up as a real-time API, put it in front of the business and see if there's actually some value here. And what I can do is I could click up here and say, I'd like to serve this model. It will give you the option then to build out a cluster behind the scenes that will spin you up a real-time API. And once you have that, you get a kind of interface that looks a lot like Swagger. If you've ever used Swagger or OpenAPI, where you can start creating your own requests against this. So I'm going to cheat a little bit and look at an example that I wrote before. And what I'm going to do is I'm going to take one of these packets. And so what this is essentially the same packet that we use to train our model. So it says that we've got a season, we've got the year, we've got the month, and ultimately what we're looking to do is get some predictions back from our model. Now what I've done is I've trained a batch model, but I've registered it as a real-time API. And now what I'm able to do is just trigger this and get a request back. And it works incredibly well. However, it is still very limited in terms of what you could use it for. There's no kind of load balancing or scaling here, but for spinning up something super simple, it's a really great way of getting started and taking a batch model and getting that running. What I'll do is I'll share all of these scripts afterwards, so if anybody wants to step through these things with a bit more time, I recommend you do, and it'll flow through building you out a model and then registering that inside MLflow. So I'm almost at time, and so I will just finish by saying that MLflow is a fantastic tool and well worth your time investing your time to have a look at. It is constantly improving, and so are the deployment techniques. And for now, it's a really great option for centralizing MLflow or for centralizing your machine learning models. With all of these things, right, there are so many different approaches, but I think generally the industry is starting to kind of converge that MLflow is probably one of the better options when you're working with a variety of different models. If you want to get in contact with me about any of this stuff, I love talking about these things. Do drop me an email or find me on Twitter or anywhere else, and I'd love to continue talking. Thank you all very much for your attention. Enjoy the rest of the mini conference, and thank you. I don't have any time for questions, but hold all your questions for the panel. Also, I really like horrible questions, so work on all of your worst questions. And when I can't answer them, I'll just give them to someone else. So it's great.
Cool. We do have time for questions because, of course, pizza is stuck in traffic jam.
Brilliant. I'll answer any questions.
It's on the
What about
way.
pizza, MLflow, or traffic jams? You're good for any.
So let's start with MLflow.
Yeah.
First, does anyone else have a question? Then I have questions. But yes. Wait, hold on.
Thank you. Thank you for this nice talk. One of the question I have about MLflow, I've looked about a year ago into the MLflow framework, and one thing I didn't like about MLflow is serialization, in the sense that it was tending to prefer using Pickle over other option for serializing. Do you know if this has changed, or if there is better integration for other serialization method for machine learning models?
Yeah, so great question, right? So what are the kind of serialization formats that we have? So we mentioned around, so what MLflow will try to do is you have a couple of different options. It will natively try to serialize into its own format, which is kind of moved towards PyFunc as a standard. But you can also get it to just serialize into a native environment. So if you want that to go back into a H5 file, or you want that to go back into just a pickle file, you do have a lot of flexibility in terms of that. The other thing that you can always do is you can always instantiate any model back into MLflow and then persist that in any other format that you like in the event that that doesn't work for you. The other thing that you have with MLflow is it can also write things back into Onyx. So Onyx is one of these formats, right, that I still don't know how I feel personally about it. Whether or not it is the future of machine learning, I'm not sure it is. Onyx, for anybody who's not aware, is the Open Neural Network Exchange, which is basically a persisted format that has a number of different runtimes in different applications. You can train a model in one language and then run it in a different language, so it gives you kind of interop. But it certainly has improved. I've never seen any problems with training in one environment and bringing it back into another. Generally things have got certainly a lot better, and it's constantly improving. I think the thing about it being open source is it is still open source, and there are still the occasional problem, but there is a really vibrant environment behind it too. So I've said a lot. I'm not sure I've answered your question, but there are a decent amount of different options that you have for persistence to kind of get over some of those bits.
Thank you.
Any more questions here?
MLflow, pizza, or traffic jams? Say your options.
Cool.
Cool.
So I'm working with Azure Machine Learning a lot, and it kind of looks the same.
Yep.
So what are kind of the differences? Why would you choose Azure Machine Learning over MLflow or MLflow over Azure Machine Learning?
Cool. Good question. So as Henk says, right, you've got both, and you've got both options. And it kind of depends on what you're trying to do and what you're trying to achieve. So I think if you're working in an environment where you train in a lot of different languages and a lot of different approaches, having a centralized way of working really helps you. Because sometimes, sometimes big vendors, Microsoft, Databricks, AWS, GCP, make this assumption that you will just focus on one kind of environment for training your models. And in reality, we don't, right? We use all different things. Sometimes it's better to train a scaled out model using something like Spark. But is that genuinely should you always do that? Absolutely not, right? If your data fits on a single machine, run it on a single machine. What single machine? Well, it might be actually that you need a load of GPUs that you don't have. So go and train in a single machine on Azure Machine Learning. If you want to train a model locally on your local machine, fantastic, do that, right? Whatever is right for you should be the thing that you use most. So when it comes to looking at where should you deploy things to, as Henk says, right, Azure Machine Learning has got its own experimentation tracking, its own model management. It really depends on what you want to do in terms of centralizing. Potentially you want a kind of cloud agnostic approach, so deploying MLflow into Kubernetes is a great option. Generally, they're pretty comparable in terms of features. You can track what you want. You can register models. The other thing that you have with Azure Machine Learning is it also supports MLflow, so you can link the two together. If you want to train in Databricks, you can push that into MLflow and have parity between that. So ultimately, they're quite similar, but I think generally it depends on where you're looking to train. If you're just in Azure Machine Learning, just do that, right? It simplifies things, it's much easier. But if you're in different places, it makes sense to think about a more centralized strategy for what you're trying to achieve.
That was a good answer.
Thank you.
Thank you
Well,
for
it was
that.
a good question.
So we talked about the training. I think
Yep.
MLflow spins up a bunch of containers for you and deploys that to the cloud and thing of your
Yep.
choice.
Yep.
And how does it do that with when you want to run them in production? Can it also take care of that part? Because we saw it a little bit
yeah.
that you sent
Yeah.
requests to it.
Mm-hmm. So there's a couple of different things there, right? So where do you, once you've trained your model, how are you looking at inference? So inference, if you're in Databricks, right, you kind of just have one thing, which is to spin up a job cluster behind the scenes, which then gives you the ability to push things to it and to get scores back. As kind of mentioned, that's a great option for kind of a proof of concept, but it's quite limited in terms of scalability. You don't have all the things that you would want from, say, deploying into Kubernetes, where you could say, actually, I want to have 15 different replicas of this, and I want it all load balanced so that I can grow this. And then as it grows over time, scale that up when you need to. So when it comes to the open source version, you also have the project aspect, which will enable you to deploy your trained model into either SageMaker or into Azure Machine Learning. And at that point, that can be used to spin up a kind of inference cluster that you can then use as part of your real-time process, where you've got some of that flexibility, especially potentially with some of the newer components of Azure Machine Learning, as well as into AWS SageMaker. So if you're multi-cloud, you can do that. But if you're just in Azure, then you've got a great deal of flexibility for inference by just deploying that into Azure Machine Learning.
Oh, so that's cool. So if I have my open source MLflow, I run that the way I want.
Exactly.
In my network, safely behind the wall in my rack. Then I can still deploy them in Azure, Azure Machine Learning, using Azure Machine Learning or whatever cloud I would like.
Absolutely right. So that's kind of the benefit, and working out. Ideally, so if someone's training locally and they push to MLflow, if someone's in Databricks and they push to MLflow, if they're in Azure Machine Learning and they do the same thing, we've got one standardized option for deploying or a multitude. And really, it's just about coming up with those patterns, right, and that kind of operating model for how you want to run. Give everybody the flexibility for where they train, and then you just standardize on, right, all of our inference clusters are in Azure Machine Learning, so we don't care where you train, but we'll productionize using that, because as an operations team, that's how we know how to work, and that just gives us a huge amount of flexibility.
Awesome.
Questions? These are great questions.
Does anyone else have a question about MLflow or Azure Machine Learning?
Pizza or traffic? generally with these things, as long as I amuse myself, I'm happy.
So cool, then I think we're going to take a small break. I want to thank you so much for your presentation. I learned a lot.
Thank you for having me.
And yeah, we have drinks in the fridge, and we will wait for the pizza.
Good stuff.
Thank you.
Thank you. Last time I did an event here,
was nice here in the audience, and I hope at home that you also had something to eat or drink in this a little bit longer break. The countdown was kind of stuck for like 10 minutes. So, but it is now time to continue with Gavi. Hi, this is your first time on the A Bit of AI show.
It is indeed, yes.
So thank you so much for joining us.
Thank you for having me.
But we always have some awkward questions before you can actually start presenting. And we call it lightning questions, so you don't have to have an extended answer.
Okay.
You can just say what
Comes to my mind.
What comes to your mind, exactly. Okay. So the first question is always, what was your first computer?
Oh, I can't remember. It's pretty old.
Okay, then the follow-up question on that. What operating system was it running?
Windows 98?
Perfect.
That's probably going to show off my age, isn't it?
Yeah, exactly. That was kind of the thing.
Yeah,
Right?
yeah.
Then, what was the last programming language you used?
The most recent?
Yes, like today maybe.
Python.
Of course, it's always Python. It's always Python. And then, what was the last thing you learned?
I was looking at reinforcement learning just this morning.
Oh, and how was it?
Complicated?
Did you manage to make anything already?
Not yet. I've got a 3-hour lecture just to read through and understand it, so not yet.
Perfect. Next time, we'll want to see your demo about
definitely.
that.
Definitely.
Perfect. So, yeah, you can take it away.
Okay.
Good luck.
Thank you. Good evening, everyone. There it is. It's on the screen. I'm here to talk about the no-code road to churn prediction. Okay, so before I start the presentation, a bit about myself. I'm Gavita Regunath. I'm a principal data scientist with Advancing Analytics. Those are my contact details. I work with a bunch of talented people, really passionate about anything big data related and AI related, and we love answering questions or just hearing from people. So if you've got any questions, those are my details to get in touch with. So today, I just thought before I get into the demo, get into the presentation, I'm just going to set the scene, right? I'm going to talk about the tech stack that I'm using or talking about today to solve the machine learning problem. I'm going to be talking about Azure Synapse Analytics. I'm going to also be talking about the Azure machine learning. And then I will talk about what does the no-code road mean? What do I mean by that? And then, obviously, we're solving a machine learning problem today. So I've picked a churn problem. And I'm just going to talk about why it's important and why I picked it. And then how are we going to do this, right, using the tech stack that I'm going to talk about? So Synapse Analytics, what is it all about? It is Microsoft's limitless analytics platforms that combines enterprise data warehousing and big data analytics. The way I think about it is your one-stop stop of doing everything big data related and analytics. So you have the opportunity to ingest, you've got the opportunity to transform and get you already prepped up for machine learning or any BI related stuff. Okay. The next thing I'm going to talk about really quickly is Azure machine learning. So I'm sure everyone here has heard about Azure machine learning. Show of hands. Pretty much everyone has heard about Azure machine learning, right? So I am going to use Azure machine learning, and it's Microsoft cloud service for building, training, and deploying anything machine learning models. But what I'm really using it for is leveraging the AutoML functionality within Azure machine learning. So that's where the no-code thing comes from the title of my presentation. But what does that mean, and why am I talking about it? And to understand it, I'd like you to just talk about what machine learning is all about. It's an extremely iterative process, but to understand the pipeline, let's just have a look at this pipeline, right? So the life cycle of machine learning looks something like this. You start off with having raw data. You get your raw data, you do a bit of cleaning. Then you might do some feature selecting, picking some right features where you think it's appropriate to feed into your model. You might do some feature pre-processing and construction. Then you go on to build your model and select your right model based on the metrics. Then it comes to the fun part where you're optimizing parameters or hypertuning or hyperparameter tuning. Then you get to this last stage where you validate your model, and then you realize you haven't done things quite correctly, and you go right back to your data cleaning process, right? So it's an extremely iterative process. It's fun, but it's also very time consuming. So the goal of automated machine learning is to automate the more tedious parts of machine learning lifecycle. So what we're going to do today is leverage AutoML within the Azure Machine Learning service. And it's going to automate machine learning algorithms for us. It's going to build hundreds of machine learning models. And what it does is, within Azure ML, it does your feature selection. It then picks the right model for you as well. It'll tune and train all your parameters, and then it'll give you an optimized model. So we're going to do that. Why AutoML? This is one of my favorite parts. For me, as a data scientist, it just makes machine learning more accessible. It empowers a range of users, right? So you don't really need deep machine learning expertise to use automated machine learning. If you have an understanding of it, you can start building models. But apart from that main benefit, you can also quickly, if you're working in an enterprise and an organization, it gives you the ability to quickly verify how good a data set is. So if you wanted to see whether can I use this data set to get some sort of predictability, you can use AutoML, right, to decide. The other good reason is, benefit is you can use AutoML to very quickly benchmark your models. Now, if any of you, like me, are on Kaggle, you can use AutoML very quickly just to give you an indication of, right, for this sort of problem that I'm trying to solve, maybe I should be looking at this particular model. So it gives you a good starting position. So let's quickly recap. We've spoken very briefly about Azure Synapse Analytics. We've talked about Azure Machine Learning, in particular how we're going to, AutoML within Azure Machine Learning. But what we haven't spoken about is the data set. What are we going to solve? And as I said before, we are going to look at solving churn, okay? So churn, also known as customer attrition, is when customers stop using a service or a product that's offered by a company or organization. Now, the reason I've chosen churn is it can be applied to a range of businesses and services, right? You've got banks, you've got Netflix now, your TV streaming companies, they all will look at churn. So that's why I chose this particular problem to solve. One of my favorite slides nowadays is to show this slide where the Harvard Business Review have done some research. I think they did research on hundreds of companies looking at statistics. And as a consultancy company as well, I've seen that this is actually true. So increasing customer retention by 5% can increase profits from 25% right up to 95%. So that is pretty good, right? So that's why I'm looking at that problem, looking at predicting churn. Okay, so how are we going to do it? Now, I've summarized it. So using Azure Synapse and AutoML within Azure Machine Learning, we can do this in 3 steps. First step, we need to provision our Synapse Analytics workspace. We then train our machine learning model using Azure Machine Learning with Spark Compute within Synapse Analytics. We then deploy the model that has been trained for us by Azure ML back into Synapse Analytics, and we make a prediction using T-SQL. And when we do all of this just from Synapse, so we're not going to leave Synapse, we're just going to do it all from Synapse and get a prediction of our data set. Few things in terms of setting up our workspaces. We need to provision our Azure Synapse Analytics workspace. Now, Microsoft has got tons of resources on how we do this, and I've got a link in our blog and our video to tell you how exactly we do this. The next thing we need to do is make sure we have access to Azure Machine Learning as well. We then set up our dedicated serverless Apache Spark pools. Now I've put that asterisk there to remind me to let everyone know if you're using AutoML within the Azure Machine Learning, we need to make sure we spin up the Spark pool version 2.4. So if you do version 3.0, it won't work. And with that, we need to also make sure we spin up the SQL pools in Azure Synapse. Once we do that, we need to create the link, right? The link basically allows Synapse to allow the Azure Machine Learning to create the model for us, and to basically, it's a communication link between your Synapse and Azure Machine Learning environments. If you don't create that link, it just won't talk to each other. The last thing we need to do is make sure we've got the training and testing data sets. So these are the 5 key steps that we need to make sure we provision or we have before we start our whole experiment. Okay, so let's have a look at a demo. So this is the Synapse workspace. And what we're going to do is, I've already uploaded my data. So if you go onto your linked, so you've got all these different tabs. And within data, if you look at your linked option, when you provision your Synapse workspace, it also comes with a data lake storage. And what I've done is as easy as just uploading all your data sets into your workspace. And then what I've done is to allow your data set to be trained in Azure ML, you've got to make sure that you're writing your training data set to your Spark table. So I've already done this as well. So if you go back to your workspace now, you will see that it's a Spark table and you've got all your columns there showing what the data set is like. Okay, so that's already been done. Now what we want to do is we want to train a machine learning model to detect which customers are going to churn and which customers are not going to churn. So it's as easy as clicking on the actions. Is it right click? It's not working. Hang on a minute. Is it that? No. One second. It usually does, but well, it's just trying to. Sorry? No. Oh, yes, that's right. Thank you, Terry. So, yeah, when all you do is the data set that you want to build a machine learning model. So let's go back to that. Yep, we right-click on that, and we get several options, right? So what we want is the machine learning option, and what we want to do is train a new model. That's all we do. So when we click on train a new model, you get a wizard like this. Now, because it's a churn problem, it's a churn machine learning problem, it's a classification problem. So it's a matter of selecting what kind of problem you want to solve. So classification. When you continue, you've got then several options to fill out, right? So we need to make sure we tell Synapse the Azure Machine Learning workspace that we want to communicate with. And because I've already linked this up, I can choose one of those. The experiment name and the best model name, those names are already populated for us, as you can see there. So I'm just going to leave it as it is. I'm happy with those names. The target column that I'm trying to predict is a column called Churn. So it's right at the bottom here, scrolling down. I simply click on Churn. And the Apache Spark pool that I've spun up is 2.4. I click on Continue. And here you've got 2 options, right? You can change the maximum training job time. So that's set at 3 hours as default. You can change it down. You can bring it down to an hour. And the concurrent iterations, I've just left it as default. What's really key here to remember is if you're bringing back the model from Azure Machine Learning back into your Synapse environment, you need to make sure your ONNX compatibility is enabled. Because if it isn't, then it won't be able to read your machine learning model into hexadecimal format to be able to do your t-predict. T-predict. It's as easy as that, and what you do is you create your run. So while you guys were having your pizza, I've already done this. And here you can see, you would see in your notification, when you click on that run, your AutoML run would have started. Another way to check this is to hop onto your Azure Machine Learning workspace, just to make sure that they're talking to each other. And you can see here, right at the top here, the status is it's running. So everything is good, right? So I know in the background, Azure Machine Learning is training my models for me. Within an hour, it's going to give me the best model. It's going to score it based on the metric that I've chosen, which is accuracy. And it's also going to register that model for me. Everything is done for me. So I can go and have a piece of cake and a coffee, that I usually do. And then I'll come back after an hour, and everything's done for me, right? So easy. So when it's done, after having your cake and your coffee or tea, you come back, and what you really want to do is make sure you deploy your model back into your SQL database where you've got your testing data set, or you've got your data set coming in, and you want to do this prediction, whether you want to assess whether your customers are going to churn or not churn, right? So to do this, I have already uploaded my testing data set into SQL database. I've played around with a lot of data sets, but I know the testing data set that I want to test on is the test orange churn data set. So again, you click on your options, and you've got loads of different options right here. And what I want to do now, after having trained my machine learning model, is to use that model to predict on the data set. And it's a matter of just clicking it again. So you click it and say, right, I want to predict on a test data set, and I would like the this particular model. So I'm going to highlight my first model that's trained. I think it was done a couple of days ago. Continue. And here you have to fill out a couple of options. Basically, you're just verifying that you recognize all your source column are matched to your model input. And if you have trained it within Azure Machine Learning, it will all be matched automatically for you as well. So you don't really have to do anything. All you have to do is make sure you click through, make sure it all looks correct, verify the details, and that's it. It's as simple as that. If you're going to run this over and over again, you'll have to give it a store procedure name, and then it's just as simple as loading the model into the database. Now, I've done all of this beforehand, and it has been loaded. So here, what I've done is, this is the stored procedure that I've executed again. And what it's done is it's taken that model in Onyx format, and it's predicted on unseen data set. And this output label here, I don't know whether you can see it. Let me just scroll this up. You've got a Boolean prediction. F stands for false, and true means they're going to churn. So it's as simple as that. And within an hour from getting your data set uploaded into your lake, you can train your machine learning model, and then you can test it on unseen data set. So that was a quick demo. Any questions? Because that's the quick overview of how we use Synapse and Azure Machine Learning. Any questions about the demo so far? No, okay.
What's the lowest cost of a Spark? The Azure SQL tool and you use other tool, which is a PySpark.
That's right.
Two together.
Yes.
And which means, so is the cost, I know a SQL tool I think comes about £800 or something like that per month.
I know it's expensive.
And so is the Spark tool is it included in that cost, or is it a separate pricing entity?
I believe it's separate. Yeah. So hopping back to my slides, it's recap time. We have, using a churn data set, we've trained a machine learning model very quickly for us. And we've done this all using Azure Synapse, right? So hopefully, I've gone through it really quickly, but we've also got a blog post that goes through step-by-step procedures if you wanted to do this again at home. It's all available on our website. We also do a lot of videos about signups and Automl. It's all available on our link. So if you want this link, you can come and talk to us. And that is the end of my talk. Any other questions?
So you had those certain customers flagged as true to churn.
Yeah.
Do you have a sense of what would be relevant in that data to cause them churn? Like, I'm looking for the action now. How do I stop this person from churning?
Yeah, then what you do is you look at it, look at the data set and try and analyze it. And I guess it will come down to what features are going to encourage people to churn, and that all comes to analyzing it. I haven't done that, so all I've done is look at data set and try and use Automl to get a model to do a prediction for me.
Okay, but you don't know what it ultimately selected as the relevant factors to select to
I've
determine
used
it
the
true.
entire data set
Right.
as features.
Yeah. Because, I mean, just looking briefly at the data that you could see there,
Yeah.
the ones flagged as true didn't look all that different than the ones flagged as false.
Well, yeah, okay, so I've not really gone through and analyzed the data.
Yeah. It is an interesting, I mean, you make a point that it's incredibly valuable to retain those
Yeah.
customers. We do analysis, but then we actually have to create action.
Yep, that's true.
Behaviors we're going to change that will
Yeah.
decrease churn.
Yeah. So you need to understand that, right? You need
Mm-hmm.
to understand why exactly have they churned and what's caused it.
The other alternative I could see is that the next step is now we allow that data set to age for a while and say, did those people actually churn? Like, are we right?
Yeah.
Thank you.
Thank you so much for that talk. Are there any other questions in the audience? Let me give you the microphone.
So once you got the model trained, how do you consume that in an industrial application? So what will be the next step after you have done the training and validation?
So once you train, the best model gets registered. And in terms of deploying it back into your, is that what you meant? So you pick your best model
Yeah.
and you deploy it back into your SQL database.
Right. So if I have fresh data coming in, unseen data coming in,
Yep.
what would be that? So would I write some Python code to execute that model, or will it be? How does it work?
So pretty much you right click, you deploy your model, it generates your SQL script for you automatically, and it's as easy as just running the script.
So I just feed in data into that unseen data into the new table, in that table that he showed me, and I run that store proc, I think is that.
Yep.
And it gives me the results back.
Yep, exactly.
All right. Okay. That's nice.
So
Thank
pretty
you.
much no code solution, right? I've not really done much coding there.
So I don't need to know anything about the Python side of things here. I don't need Keras, or I don't need any scikit-learn or anything like that.
Not at all. So what you've seen there, and if you go through the blog as well, you don't need much coding experience.
Got it. That's nice. Cool. Thank you.
Anyone else? Oh, there.
Hi. So just following on from this gentleman's question.
Yep.
So is there a way to find the R2 score of the features?
Yeah, so if you go back to your Azure ML and your experiments, there'll be your entire stats there, right? It'll give you the ability to look at some of the features that were selected as well. You've got a range of options to look into.
Okay, all right. Thanks.
Sorry, just a quick question.
Yeah.
So what happens if you get an error based on the data that has been uploaded? So if the data is not fully, to the right format, how do you work around that?
I have quite a lot, actually. Just keep going now. Well, I'll be honest. What I really did was I dived into the problem, like I was telling you before. I spun up a SQL pull version 3.0, and I just thought, I'm going to click it. I'm going to dive into the deep end and see what happens. And I hit pretty much a brick wall. I went back to Microsoft's documentation, and it's a pretty good, it just highlights everything for you step by step. And if you follow it, you get out of the mess like I did.
Any more? Cool. So I've seen that. I also have questions. It
Okay.
was like really cool there where you showed me a lot of things I don't know. I use Azure Machine Learning, but
Yep.
I never used it like kind of in combination with Azure Synapse. So I know it is kind of a lot of work to set up Azure Machine Learning kind of the way you want.
Yep, yep.
So how do you connect those two? Do you set up Azure Machine Learning first and then you go in a drop-down, or do you do that with?
Well, I had Azure Machine Learning. Synapse was very new to me, so I had that running already, and then I provisioned Synapse and made sure that is it the link service? Use the link service to make sure that it was connected.
Okay, that's what the button is for. I've seen that a few times.
Yes.
Okay, and then you link them, and then they kind of work.
They talk to each other, yes.
Oh, that's pretty
how
cool.
I think of it. It's like saying, hey, I need to talk to you. Can you give me some access? And they're like, if you put your right password, they talk to each other.
Yeah, but for your automated machine learning,
Yeah.
you kind of set up your own training clusters in Azure Machine Learning.
Nothing at all, no.
Okay.
So it does it all automatically from
For you.
Synapse. It talks to Azure Machine Learning, and it does it all
Starts
for
the
you.
job and
Yeah.
starts running it. Okay, that's pretty cool.
Yeah, it is cool.
So thank you so much for your time, and we will see you in the panel with probably a lot
Yes.
more questions. So we will be. Okay, first an applause, of course. I forgot it. It's new experience that we have actual audience and not only people on the stream. So next up, in like 2 minutes, we're going to connect Richard's laptop, and then we will be back. Hi everyone, and welcome back to the A Bit of AI show. And for the final talk, we have a very special someone we're very lucky to have on our show today, and that is Richard Campbell. He is a very, very, very good storyteller.
Thank you.
One of the best I know. I always enjoy watching your talks, and I think I've seen them over and over, and every time you have something new and exciting in it that I'm like, oh, I didn't know that about Microsoft. Oh, I didn't know that about the history of something. So this is a new talk. You're going to premiere it here.
We'll take it out for a test run, see what people think.
Yeah. So I'm very excited. So let's get started.
Thanks, Henk. And thanks for having me here. It's exciting to be back in London. It's been a couple of years, which is strange for me. And it's also not normal for me to be here in May. It's nice. Normally I'm here in like January, and it's not that nice. Most of the time I work on podcasts and collecting stories from others. And every so often I get a chance to bring those stories together. And you've probably run across me doing history-related materials, because that's one of the opportunities that I have. Having collected stories from so many folks, you get to assemble together narratives. Artificial intelligence, to me, sits in a different category in that it is an emerging technology. I don't like the name artificial intelligence. I think it's an umbrella term. It's old. It's from the 1950s. And it really is an umbrella term for technology that doesn't work yet. Because as soon as it does work, it gets a new name. It becomes image recognition or statistical planning or, or some kind of machine learning model. So I'm always concerned when I hear folks talk about artificial intelligence directly to say, look, what are you really talking about when you say that? I mean, why wouldn't you talk about machine learning? We've seen a couple of great machine learning talks today already, and you know they were machine learning talks. It's almost unfortunate they're under the umbrella of the AI talk, because they were both related to data analytics and some really useful capabilities with some of the new software that we have these days. Now, the part of the problem I have with AI, and that term in general, is what it does to the public. Because they hear it and they think HAL from 2001: A Space Odyssey. For a good reason. That's that movie's from 1968. The first time that most humans ever heard the word artificial intelligence, it was a robot on a spaceship that tried to kill everybody. It's kind of setting us up for our relationship with the technology. And we know, because we are in this space, that the technologies that we're working on, these machine learning approaches and so forth, they are specialized intelligences. They are a technology where we provide a set of rules and a set of outcomes. It generates its own rules, and we go forward from there. And often, again, when I'm talking to the public, I'm dealing with folks who think of HAL, of a generalized intelligence. And so I've worked hard to come up with a way to talk about how far and different those two things are. And really to argue that there's not a lot happening in that space at all. And I recently ran across this book of that title. So Algorithms Not Enough is actually a book by Herbert Roitblatt, and he's an MIT scientist, and he's really refreshed most of the thinking around generalized intelligence. It's one of the densest books I've ever read, and I don't know that I can recommend it to you in the sense that it is hard work to read this book. If this stuff really matters to you, if you want to be part of this, of shaping this aspect of our society, which is the tools we're working on right now, it's probably worthwhile. But let me give you a little bit of a summary. What he recognized from the generalized intelligence is an awful lot of assumptions that we take into what it is to be an autonomous being that we often take for granted. And so he hit on 6 key points of things that, for the most part, we're not really working on, but are necessary for a generalized intelligence. So he talked about being able to reason or to explain a cause for an event, right? When we talk about reasoning. Now, that's normally our job, to help us summarize or organize information so that we can reason against it. The idea that we would ask the machine to do the reasoning part is quite a big jump, because it cuts into sort of logical judgment parts. Not my slide. This is not fine. Another aspect is the strategic planning, and again, a very human thing that we normally do. That being to look at a current state, figure out a set of objectives we have, prioritize those objectives, and then begin an iterative planning process of constructing a plan, executing on it, managing it, measuring its results, modifying the plan, and repeating. You know, we do have iterative models for machine learning, but most of that executive function The rules around when we choose what the priorities and so forth, we're the ones setting those rules. And so the idea that the machine would take on that role, that strategic planning role, is a very different set of functionality. The ability to learn. Now, we are building learning engines in a sense, although we are definitely setting a set of governance. We're definitely setting the inputs and the outputs. That way we know what the outcomes we want and so forth, and then seeing how well it learns within our set. And typically we select the moment where this technology learns. We rebuild models, we retune models. That's our opportunity to do new learning. A generalized intelligence would need to continuously learn, or ultimately to alter its own structure based on the information it's receiving. And that's another problem space that's pretty unique. And part of that depends heavily on the ability to perceive. To perceive is to actually realize or understand. And what you're trying to realize or understand is this data that is relevant to altering behavior or to learn from? That's a heavy piece of judgment or reason. So perception and reason go together. And again, it's not something we normally do with the machine. That's our job. We tend to use these machine learning models to help us do that job. But ultimately, we're the discriminator on all of this. We handle the perception role. So when we start to back up and think, how would we have a machine do all of these things? It's like, how would we codify a recognition or a perception of relevant data? And two more. One is inference. I was trying to find a good graphic for inference. And I'm beginning to believe that Gary Larson actually owns the I Ching of thinking. There is a Gary Larson comic for every problem, and this is the best inference graphic of all time. You know, once again, in a single frame, he has told an entire story of what we can infer about what happened some period in the past. This is a very hard problem to do programmatically. To look at a state of data and infer a past or a future from it, right? Rather the explicit data, you know, think about all the things you need to know why the cat has peg legs, right? Funny for us, that's how easy it is for us. Gotta write some software to do that, right? Generalized intelligence has to do some stunningly difficult things that again are inherent to us and not programming models we normally think about. And last but not least, and I think it's interesting that this was of the six also essential, which was our ability to represent knowledge. I mean, automatically I think in terms of when we are building these specialized intelligence or giving them specific tasks to do, they are always representing knowledge. That's what they do. But that's us having the tool represent the knowledge we intend to represent, what we found, perceived, and recognized as valuable. It would be quite a shocking thing to have a piece of software that created inference of new information and then tried to convey it to you. Right? That is that sense of sentiency. And we're very susceptible to those ideas, right? Humans anthropomorphize. We tend to lend an air of sentiency to ridiculous things, like our cars. And so these machines, which we've been talking to for many years, we often give an air of consciousness, even though we know it's not true. And in fact, if we did see those behaviors ever happen, we would be disturbed by them. And so, but if we're going to write systems that would become autonomous or sentient, we would expect this. Now, those are sort of the big six, those elements. They're not the only ones. And in Roy Blatt's book, he focused on those and spent chapters on how you would think about each of the things, what it would look like to model them and be able to have them work together. And then he went on and rattled off about 15 more problems, like if I give you a small number of examples, can you derive a larger set from? If I give goals from it. Again, things that experienced people could typically do, right? Or doing counterfactual interpretation. Right? I mean, it's a strategy that creative people often use when asked to solve a particular problem, is they go and look at the opposite problem, right? Because that can affect your mind to look at it from different ways and possibly give new entrances to solving problems. We've been successful with specialized intelligence because we do a whole group of very important executive functions to be able to box that into a shape that we can execute on. And so, we've solved chess. Also solved it like 25 years ago, right? Deep Blue was the machine that beat Kasparov back in the day. It was a decision tree learning model. Long before we had adversarial networks and so forth, they built it a top-of-the-line decision tree model that could prune sufficiently to run quickly enough to actually play chess at a reasonable pace and beat a grandmaster. And of course, this technology developed by IBM continues to this day. It's worth noting that the computer, this massive RS-6000, a huge machine from 1997, has about the same computing power as a Nintendo Wii 20 years on, right? Like Moore's Law makes your cool new tech from last year just not that cool. And of course, the last iterations we saw of it were Watson, although we know now that all decision tree models have an n+1 problem. And so as the tree gets bigger, the performance goes down. And pruning becomes the biggest issue over time. And you can only go so far. Which is why, largely, by 2011, 2012, as the modern neural net emerged from Hinton and Yee's writings that turned into these current models, they superseded all of them. And we're still learning exactly how they work and even what they're capable of. In AI communities, there is Hans Moravec, and he said this back in 1988, that it is comparatively easy to make computers exhibit adult-level performance on intelligent tests, like playing checkers, because it was before they'd cracked chess, but difficult and possible to give them the skills of a one-year-old when it comes to perception and mobility. So what was he talking about? Well, the reality, of course, is he was talking about exactly what had been going on, is they'd actually taught a computer to play chess in the 1960s as well as could be played. It's not that complex a game, and they were working on the chess problem. The reasons we're effective using technology to solve what are nominally complex problems is because they have very defined rules. We've largely abstracted those complex tasks from reality and put them in a structure that has its own set of semantics and symbols that we can then programmatically infer and derive functions from. And this is the same of image recognition and so forth. Like all of those things have very specific sets of semantics around them. And we have not done as well in defining reality. Walking down the stairs represents a remarkable set of problems, much less identifying a screw in a box of screws that's different and lifting it out of that box. And so we have this strange dichotomy where we have software we've built, machine learning models, that is remarkably capable of doing tasks we find challenging, like playing grandmaster level chess, and yet can't do basic perception tasks that we expect and see children do successfully. Now we are addressing that problem. Like there are bits of technology out there. I don't know if you've ever run across this, another MIT technology, and I realize after assembling this deck, I talk about MIT a lot in this. This is Dactile. So Dactile is a way to train a robot to have very agile physical manipulation. So it learned to flip a coin, to turn this cube over and over in its hand. And the way they did it is they created a digital twin of the hand and the block so that they didn't have to run it at physical normal speeds. That they did in digital reality, learning to flip the block over and over and over again, hundreds of thousands of times, until they got them all that worked well, and then they manifested an actual robot that could do it. Which is cool, and not how humans do it. Right? So we are compensating for our inability to create perceptive and reasoning software with brute force and high-speed computing. Right? That Moore's law is solving the problem. And so when I have conversations around this, you say, well, look, Dactile's doing this. I just recognize, no, but we're still not addressing the actual issue of what an artificial generalized intelligence needs to do. You don't get to go off and do mass compute to figure out a movement. You have to be able to infer what those movements would need to be able to reason around their ultimate consequences and judge whether that's the appropriate activity, and then find a way to actually get to that movement. All hard programming problems. Which makes us be able to think more deeply about how to build terminators. Now, the great thing about the Terminator world is that, well, an awful lot of the public thinks this is AI. It wasn't. Do you remember how they talked about the Terminators? They were relentless. They were single-minded. They were exactly the opposite of a reasoning creature. They'll just keep coming until they achieve their goal one way or the other. The only reasoning mind, in theory, in that universe was Skynet, right? That there was a singular intelligence that was spawning all of these things. And same with HAL. That HAL was sort of a one-off that sat inside of the ship. It was supposed to do this thing, except for that part where it got a little homicidal. Details. We'll call it a bug. But those are science fiction. And part of the problem we have with artificial intelligence today is too much science fiction, not enough science fact. When we talk about killer robots today, we talk about drones. And we happen to have a war that's particularly relevant in the West, because there are other wars going on, that is using drones extensively. Is this artificial intelligence? No, right? This is a Turkish drone called the TB2 that for the most part was being used as a surveillance drone. It allowed the Ukrainians to identify Russian soldiers' movements and then make an executive decision on how to react to that, typically with artillery. Although lately, they have been slinging missiles to this drone and then using it as a platform to fire the missile itself. It's a weapon system. It's autonomous? No. Remotely piloted? Yes. Now, a more visceral version of this is the drone that was recently provided by the Americans to the Ukrainians called the Switchblade. You may have seen this on the news. This is a small drone, maybe 4 kilos. Fits in a tube you can wear on your back. It's got a short lifespan. You stamp it into the ground, you use a pneumatic impeller to fire it into the air, an electric motor fires up, you've got about 15 minutes of runtime. You have a screen, I mean, you're literally at Sony PlayStation kind of, working from a screen to look from the drone at your immediate opponents, not that far away. This is a short duration drone. However, it carries a 40mm grenade explosive in it, so you can fly it into your target and kill them. Pretty intimate. But still very much completely human controlled, right? It is the equivalent of a super smart grenade launcher. You can take a 40mm grenade in a tube, fire it in the air, and if you can figure out where you need to put it to, you can do essentially the same effect. This one just goes a little farther, a little more precisely, and you get to watch a video of your grenade headed towards someone. So let's talk about the Karga 2. This is another Turkish drone, largely derived from the common quadcopter model, only this one has a 40mm explosive fragmentation grenade on the top, and an optical system tied to an image recognition system that identifies specific soldiers. In March of 2020, it was deployed in Libya against a opposing force to the Libyan army, and it targeted an individual soldier that they had recognized was the leader of the group, chased him down and killed him. No pilot involved, no remote operator. Crossed the line yet? It's the same software. No artificial and generalized intelligence at all. It's a machine learning model you've probably worked with. It's an image recognition model. It's just been fully weaponized. I would argue all of the concerns we've ever had about generalized intelligence are moot, because this is what we can do with specialized intelligence. Long before we can build a super intelligence that might destroy our world, we can destroy it with this stuff just fine. And same for specialized intelligence working the other way. Have you heard of the Halicin? It's an antibiotic. It's a new antibiotic, one of the first ones in more than a decade. It's profoundly different from any other antibiotic we've ever found, and it was found by a machine learning model. Now, the compound involved was already made by people. It was actually originally a drug being experimented with to help treat diabetes. It failed miserably and was put on the shelf, along with thousands of other compounds. But again, MIT, they built a model to look for underutilized compounds that might be able to interact with molecules of relevance. It was only a few thousand molecules that were working against a few thousand different compounds. And in a matter of 3 days, it spat out a series of choices, although this was by far the highest ranked one, and said, this is probably a very good antibiotic. And then they applied those same models to a human tolerance test, another machine learning model, and said, and highly tolerable by humans. because it approaches the antibiotic process completely differently from most antibiotics, it's almost entirely resistant to antibiotic-resistant bacteria. It will kill them all. It's been mostly tested with mice and with remarkable success. And it's now in the FDA trials process to become a new antibiotic. It's a breakthrough, and it changes the way we think about how we make medicine. We can go further with that, but it's still just a machine learning model, right? A bunch of good ones directed by some very smart people who use the models differently than they did used before and derive something completely new from it. We've heard about Go, the game that could never be handled by chess, like chess had been handled until the AlphaGo model came along, which took 2 years to develop by the DeepMind folks. Although right after they succeeded in 2017, they worked on AlphaZero. And AlphaZero is where they changed the model, where I'm no longer going to teach you by watching you play games. I'm going to teach you by showing you the rules and let you play yourself. And the model they trained there in a month was then better than the AlphaZero, the original Alpha model, the AlphaGo model that had taken them 2 years to train. And that was pretty cool. Apparently it upset the Chinese, because Go's their game. But that's hardly important. It's still just a board game. But that same system has now been applied in AlphaFold. And AlphaFold is a machine learning model for understanding protein folding. So protein folding is one of those holy grails of medical science. We're made of proteins. There are lots of them, and they fold in very complex fractal ways that are hard to understand. We only understand the folding of a handful of proteins out of the hundreds of millions of potential combinations. And so much like the ImageNet test back in the early 2010s that kicked off this current neural net revolution, they run a similar competition now for protein folding. It's called the Casp Trials, and it's been going on since the 90s to say, can we use software to understand protein folding better? AlphaFold only got involved in 2018. The trials run every 2 years. In 2018, they did okay. This was the second try in 2020. In 2020, it scored a 92 percentile. The previous highest score had been 58. It got all of the protein folds that were known right, and then showed a bunch of others we don't know, that we're only a few months away from the next trial, and they haven't finished testing all of the results from the 2020 results. But there's a distinct possibility that we now have a model capable of understanding protein folding better than any other way. And that's unusual. Most machine learning models that we've seen are cost reductions in human analytical capabilities. Even Halcyon could have been found by a person. Somebody could have taken that drug off the shelf and had tried it in an antibiotic trial and would have gotten the same results. This is different. We've spent decades trying to do this, and we've never found a good model. So we showed the computer what we wanted to have it do, and it found a set of rules we still don't actually understand. So, is it sentient? No. We gave it a well-defined problem space, and it's been able to derive a set of rules more complicated than we've initially been able to perceive. And it's as empowering as fully autonomous killer drones are threatening. That's how good tools work, right? They're able to do as much harm as good. It's really up to us as to how we handle it. I mean, that's really all I wanted to say about this. I did include I was playing with some ideas of where to go from here. This is kind of a harsh moment. But the other question that I get asked routinely is about AI replacing jobs. And I have put together a deck on that a couple of times, and I'll run it for you if you're interested. Because I always lead off the argument with, don't worry about artificial intelligence replacing your job. That's what automation does. Right? And AI can be a form of automation, but it's not required to be. It's a different thing. And you can jump back to the original complaints about automation, right? The Luddites, just up the road. Now, if everybody's heard the term Luddite, but do you know the story? In 1811, so 200 plus years ago, as the steam world was beginning to become a thing, the first set of automated looms arrived in Scotland. Now, England at that time was already a big manufacturer of clothing. They were taking cloth and weaving it into, they were making cloth and making clothing from it. And so it made sense, as there were now automated looms, to start building out these machines to make more cloth. And the weavers that already worked there found it threatening and destroyed the machines. And for the most part, that's where most people know the story. It ends there. What happened after that? The machines got rebuilt. And the folks that had destroyed the machines got retrained on those machines. And they made more cloth, a lot more cloth. Enough that they ended up employing more people than they employed when they were using manual weavers. And clothing changed. Before the automated loom, you typically only owned 2 or 3 sets of garments in your life. It was normal that you had the stuff you used on the farm, the stuff you went to church in, maybe something for your wedding, and whatever you're going to be buried in. But as cloth became cheaper, people bought more clothes, which increased the demand. And it turns out that's actually what happens with automation most of the time. There's a disruption, but then the market transforms. It used to be the only way to book a flight was through a travel agent. Then the internet came along and it provided automation. And most travel agents went out of the business. Not all of them. Some of them were specialists. However, now people could book their own flights on the internet and using the web. And they booked a lot of flights and a lot of hotels. And the travel industry grew by 2 orders of magnitude. Many times the number of jobs that were displaced by manual travel agents' work. We made a larger industry. That's the nature of automation. We're getting automation in the grocery store, right? We still, for many places, it's still manual checking. And this is a job that folks are defending, the person that will actually scan all the groceries. There's a bunch of ways you could automate this. I mean, these days we literally have robots capable of doing it. This is a Baxter. Have you ever seen a Baxter? They're about 20,000 pounds. They are like an industrial robot and they look like an industrial robot, but unlike an industrial robot, they won't accidentally kill you. If you ever see industrial robots building cars, those machines are very powerful, very fast, and very indifferent to how squishy you are. But Baxter has sensors all around him and is aware of you. And I've seen this done where Baxter was making a cappuccino, because yeah, Baxter can make a cappuccino. And when you get too close to him, he leans away from you, which is creepy. But he doesn't stop making the cappuccino either. Now, Baxter's not packing groceries here. Baxter's doing something creepier. Baxter's packing another Baxter. But that would be one way to automate grocery packing. And of course, we do have, I presume in the UK as much as we have them in Canada, the self-checkout, or how I hate my self-checkout, right? Which has questionable capabilities, but a great way to reduce costs. But in the United States, Amazon has Amazon Go, where every grocery item is tagged with an RFID tag, and your credit card is as well. And so you register your credit card in advance, you walk into the store, you pick up the things you want, you walk back out again, and it just charges it to you. That's pretty good workflow. It's a whole lot of automation, doesn't need a lot of clerks. So, what I left off this list was, I order my food online, and it shows up at my door. But those are the other kinds of disruption. Automations apply to all these things. The automation that's coming is automated driving, not generalized automated driving. That's a long way away. It's a very difficult problem. And doing a little bit of driving in London makes me realize this place gets it last, because it's tough to drive around here. Where did all the bicycles come from? I go away for 2 years. There's bicycles everywhere. But long-haul trucking here, and especially in the United States, on the continental Europe and so forth, is a huge amount of transport. And it needs to be done by humans. And those humans have a limit to how much time they can drive. We don't want these big, heavy trucks being driven by people who are tired. That's dangerous. So we typically limit it to 8 hours a day. A fully autonomous long-haul truck would drive 24 hours a day, or triple the productivity of the tractor, and also substantially reduce the cost of goods. Specifically on bulk goods, more than 60% of the cost of a head of lettuce, transport. It has a short lifespan, it has to be moved quickly, it has to be kept cool. It's cheap to make, it's expensive to get to the store. So while we're concerned about the job disruption that automating this is, we also have to acknowledge how much the price of food is going to go down when we reduce that shipping costs. And it'll probably be long haul first. you can imagine that as the truck gets close to the city, because driving gets more complicated, then it'll go into a yard, drop its load, pick up a load that has to leave from the city and go back out again, and it'll be human-driven trucks that will handle the last mile work, which is also a better quality job. You get to go home at night and reduces the cost of infrastructure overall. This is automation. It uses AI-related technologies, but it's actually automation, and it's disruptive. And it's what we see over and over again with these technologies, is that you are amplifying work. You are being able to use technologies as tools. We started with sticks, and now we're at machine learning models in the cloud. Still a tool. The generalized intelligence is the construct of science fiction. We're a long way, well, we've realized science fiction before. You talk to the guys who made the cell phones, Star Trek fans, right? And that's the truth. That science fiction does inspire. Is there a serious initiative to build a generalized intelligence? Not that's publicly known. But we're starting to get the shape of how difficult the problem is, and we're a long way away from that. And we don't need it for all of the work we can do to benefit this planet. Thanks for your time. Don't want to keep anyone too late, but I don't know there's questions that can field off of that, other than what do you think? Can I turn this into something? You like that? Thank you.
Thank you, Richard. That talk is definitely approved. I will enjoy that listening to it again and again. Does anyone have a question? Let me bring you the microphone.
I have two questions. Very nice talk. Thank you very much. And I think you've honestly said that AI is probably hyped up a bit too much. What we see as what
it's how we raise money. It's very effective.
Yeah, I think it's probably machine learning is the most sensible way to say where we are today.
Yeah, I think machine learning represents our best. I mean, machine learning existed before the AI hype train when it was decision tree driven stuff.
Yeah.
We had data mining and so forth. In the introduction of these new neural net models into machine learning is what's been transformative, but it's just an umbrella.
Yeah, I would just slightly differ from you, like looking at the way how the Ukraine war is going on, and that's kind of changed our perception of war completely. In a sense
I think it's a social media war.
Yeah, and plus also the fact that the things like tanks, the way they are becoming vulnerable now, with the new missiles. So do you not think that the Javelin missile, for example, and the NLAW missile, they have some bit of something beyond machine learning? I think the way the computer vision is working.
They very much are machine learning models, right? The U.S. parlance is it's a brilliant weapon, and a brilliant weapon is that it has detailed imagery of the type of tanks that it's being shot at, and so knows the weak points and targets directly downward. Now, as a military weapons buff, I know that the anti-tank missile has disrupted tank warfare since the 1960s, okay? The Russians happen to be using a combined arms tactic poorly that makes them far more vulnerable to those missiles. There should be infantry around them, not allowing those missile teams to get as close to the tanks as they do. I don't understand why the Russians are not using tactics that have been known for 40 years to defend their tanks, but they're not. And so there's a big use sale on tank turrets right now.
Right. And coming to self-driving cars, again, I think there's a lot of hype over here.
Lots.
Driven by Elon Musk saying that I'll do something by 2019, 2021.
I don't believe him.
Yeah. So do you think, let's take long-haul trucking, that looks like a interesting...
It's got the perfect ROI. It's a simpler problem because it's highway only, depots only, a much simpler driving model, and is already got safety problems because drivers are tired, and it has immediate returns. So I think the American licensing model makes it easier for them to do that there. Nevada has already licensed autonomous long-haul trucks because there's nothing to hit in Nevada. Right? It's very empty. There's more than just Las Vegas. Right? It's a big Big old desert with some highways on it.
So if you take a motorway of Britain, like an M4 or I think the crowded ones are M25, for example, it's quite busy actually. I think. Do you think we'll see some kind of autonomous driving happening on an M25?
I think in the general, the UK is going to be a tough case. Your roads tend to be smaller. You've got a limited amount of space.
Yeah.
You've got a lot of people per mile. I once heard that if the US was populated at the same level as the UK, there'd be 1 billion Americans, and that's a lot of Americans.
Too many.
But let's look at German highways and just how many trucks are on those highways. And so when the German government could look at the idea of, I can reduce the overall number of trucks because the trucks run around the clock, and I can make my villages happy by saying, you don't run during the day, you run only in off hours. So maybe we only get 16-hour utilization instead of 24-hour utilization, but it's still more than we got before. The net number of trucks goes down. And so I just don't know there's that much, from my perspective as a Canadian, I don't think you have long haul in UK. Like, it's not a thing. But it certainly is across Western Europe. So I don't know that it's particularly applicable here. It'll come later, but we'll see. There are different places with longer hauls where this makes a lot of sense. The United States is very, very empty, and those drives are long. I've done them a few times, don't recommend it. And if I could have had an automated driver for that RV when we were doing those tours, I would have, because the driver we had was a little nuts. But I do think it works across Europe with good roads and good rules.
Thank you.
And I don't think it's that close, but this is the simplest problem we have in the automated space. And it has really good returns, so there's a lot of pressure on it.
Hi, this is fantastic.
Thank you.
Just an ancillary point, going back to the AI and will it take over jobs?
Yeah.
What kind of views do you have or advice you have for those who are really fearful of that notion, and how could their fears be assuaged in any way? What could they begin to do, given that jobs are being automated, but what can people start to do to think about how they transition from the world that's currently is to where it's going?
And I think we've seen a bunch of this in the pandemic. We've lost an awful lot of traditional low-skill workers, largely to development. We needed the workers, right? We're running at about a 20% unfilled job rate, and those folks that learned development over the course of these past 2 years, they're not going back to the shops. We can all tell that. But and that answers the question ultimately, which is that you need to reskill. Mm-hmm. And really, this is the job that we should expect from our government as we do introduce technologies that are disruptive to work, that you reskill those folks. The wisdom of the folks that were building the factories in 1811 was not to arrest, charge, and jail the Luddites. It was to put them to work, right? That they should be first in line. They actually have significant domain experience in this space. So really, this is part about just being a good human, right? Of being conscious of we are disrupting folks and we should take care of them, but also recognizing that it opens up a broader opportunity. But you're going to have to learn, right? You are going to be faced with change, and that's concerning for folks.
I know, because people are really resistant to that. I'm deep into my 50s, and I took the self-taught journey to learn how to code and become a software engineer. So I'm really into that kind of learning arc. But given that government is not investing in the kind of general population and upskilling, I was just interested in terms of if you had any particular views.
I think it's also important that we remember, as your parliament goes in, that we are ultimately government, right? It is a government of the people kind of thing. And so it's up to us to insist, right? They only get to ignore us when we let them ignore us, right? We're now in a place where we recognize the issues around social media. This is a normal thing that happens with every technology. The car came first. The driver's license came later. It was only when there were enough cars and enough disruption that civilization said, maybe we should have some rules. And then we insisted on those rules being introduced over time, because the folks making the cars and driving the cars like it the way it is. It's all of us that have to change those rules. And the same is going to happen with employment, right? That we have to put pressure on the system because it is iterating faster. But for the most part, if we can keep people on the upside of the curve, the other side of automated driving is a reduction in cost of living, which, by the way, has actually consistently happened. The number of hours you need to work to live, except for real estate, which is a separate problem, has consistently gone down. So much so that now, in the past year, when it has gone up, for a variety of reasons, we're really kind of upset about it. Because we've gotten used to food gets cheaper. And there's a reason for that. We've gotten better and better making it more and more efficiently. Now, to some costs that we should probably be paying back. A little less fertilizer, a little less long-range shipping. You don't really need tomatoes from Peru. We can reduce the impacts that our ability to industrialize food has caused. Maybe, and that could raise the price a bit at the benefit of us all long term. But overall, the number of hours worked to create a survivable environment has never been lower than right now. Right? We live in a very good time. We are also fed far more information than we've ever been fed before, so it's hard to feel like we're living in a good time. We arguably know too much. The one thing we can't get to is the ignorance is bliss thing. Although you do have a certain number of folks advocating for that. If you turn off all your social media, turn off your phone, and just stare at the wall, the world's pretty good. But if you can also learn to filter and restrict that information and understand that it's worth letting information digest for a while and look for raw sources of knowledge, not the refined ones that are designed to sell you soap, you'll be better off. It's a challenging time for humans right now because we are living in an environment that we've never lived in before, and we're trying to figure out how to live in it. And part of that is we need to introduce some new rules. That's happened over and over again since the Luddites.
Thank you.
You didn't ask me the questions, Henk. I'm very disappointed.
Oh, you wait for it. We still have a panel to go. I have some in store for you.
Okay.
So we will be back in 5 minutes. We're going to set up the panel, and then I'm going to ask everyone all awkward questions.
There are no awkward questions, Henk. Only awkward people.
to the Bit of AI show. In the Bit of AI show, we talk with people from all over the world about what they are doing in their daily life in AI. And today, we have a panel with like 3 awesome people that just gave a talk here during a Bit of AI live session. So we have Richard, Terry, and Gary here. So let's do a quick round of introductions. Let's start with Richard.
Hi, I'm Richard Campbell. I'm host of .NET Rocks and Run As Radio. I've been writing software since 1977, although I was young then. I'm not so young now. And I get to travel over the world talking about technology, and AI is one of them.
Thank you.
Hi, I'm Gabby. I am a principal data scientist with Advancing Analytics. Really passionate about anything data science and machine learning related. And yeah, that's me.
Welcome.
Hi, I'm Terry. I run a data and AI company in the UK, and I'm also a Microsoft MVP for AI. Also, I'm very good at moving microphones.
So thank you so much, everyone, for joining us. And you did some awesome talks, all kind of different topics and subjects. But let's start to get to know you a little bit better before we dive into some other questions. Richard.
Yes.
Yes. So we have something called the lightning round, which
Okay.
Amy and I did like kind of always after the show.
Mm-hmm.
But someone told me it would have been better to move it in front of the show to grab everyone's attention. So that's what we're going to do.
Okay.
So the first question always is, what was your first computer?
My father is an electrical engineer who built cash registers. For my first computer was an S100 bus machine built as a cash register running an 8800 processor.
I don't even remember that one.
It's like 1975, man.
Is that the one that had like 3 error messages?
No, that's 1977. That's a new machine. The first PC I had in my house was a TRS-80 Model 1. And that had 4K RAM and a version of BASIC that wasn't made by Microsoft. It was a tiny BASIC. And it had 3 error messages. What, how, and sorry.
Awesome. Next question. What was the last program language you used?
God, I hate that it's Python, but it is.
It's even Python.
Yeah, it was Python for me too, because I was doing some data work, and it's the easiest way to pull a bunch of stuff together. And so, yeah, I wrote a little Python off to consolidate from 2 data sources and push it over to a model.
Yeah, really Python is taking over the world.
Yeah,
It's
I mean, if you'd asked me
everywhere
like a couple of days earlier, I was doing some C#, but nope, if it's the last one, it's Python.
So did any one of you try like the Python thing in the browser yet?
Not yet.
I've tried Python in lots of different places.
Maybe not in the browser. I've got a different one. My last programming language that I used was not Python.
Wow.
I know,
Oh.
I know. Yesterday, like a true data scientist, I wrote DAX in Power BI. Because that's where all good data science nowadays is made in Power BI. So
What did it do?
I have no idea. I don't know how DAX works.
So it just looked pretty.
Exactly. It worked. I don't know. It's the most basic of measures. I have no idea how to use DAX.
Oh, amazing. So next question. Let's move it to Terry. Yes, you're holding a microphone already.
I'm here.
So that makes it easy. What was the last thing you learned new?
The last new thing that I learned. I would say that the last new thing that I learned, oh gosh, what would it be?
It doesn't have to be with computers. It can be just a thing in general.
Yeah, so I would say the latest thing that I've been learning is I've been reading a very interesting book called Atomic Habits, which is all about how to, how to make me a better person. And so very much like machine learning, right, incremental changes to do things. I'm apparently making small incremental changes to solidify new habits. And I think that's a really interesting thing but it's a very interesting thing when I look back at small things that I've always done, and I think with everybody here and everyone watching, like you've made small habits to further always improve yourselves from an educational perspective by coming here. And when you read things like that, it's like, oh, great, and it highlights some of the good things, and then it highlights all the really bad things that you do and how easy it is you slip into bad habits. And so that's certainly something that I've learned recently.
Okay, now I'm interested in like which incremental thing you have done last.
I think so. So for me, it's about I've made so many bad ones today already. It's about all the healthy choices that you're meant to make, right? And all these small things, so you don't do a negative behavior, but you think about the positive behavior. And so I'm always trying to think about the positive behavior. So I only had 2 slices of pizza, and not a whole pizza.
A good start.
Exactly, exactly. Small changes, 1% every day, right?
Oh, perfect, perfect. Okay, next question. Yes. So you have seen like a lot of projects in AI.
Yep.
Probably you have seen a lot of data. You have made a lot of things, models, things that automate.
Yeah.
So what was the most awful thing you ever had to make? You were like, I shouldn't have made that.
I don't know how to answer that question because I've always had a choice whether I wanted to get involved in something that I felt comfortable with, or if I was not comfortable with. So I've not been involved in making anything awful. I've always enjoyed what I was doing.
Okay, what have you seen? What have you passed off? That was like, oh, I can't touch my fingers on that.
I think I was asked, and not with advancing analytics, but my previous job, whether I wanted to get involved in defense-related projects, which I didn't really want to get involved. So I said, no, I'm not really interested. I'm not the person for it.
Okay, that's a good one. Yeah, I can imagine that. Was it okay?
It was fun. I think they gave us a choice. If we didn't feel comfortable in creating automated missiles or architecting something that could harm people, then we had a choice at the end of the day. We could say whether we wanted to work in it or not work in it.
Excellent. That's nice. That's good. So back to Richard.
Yeah.
You have been researching AI for, I don't know how long, but definitely for a long time you've been watching it.
Mm-hmm.
So what was like kind of the weirdest thing you saw someone making?
Oh man, people make some weird stuff, right? Like no two ways about that. A lot of sewage flow monitoring. Like listen, you just take for granted that when you press that lever on that toilet, stuff goes away. There's a lot of thinking involved in all of that. And so, yeah, watching the guys who do the flow models for how do you treat in primary treatment and deal with the chemistry involved in that, depending on what people are putting down the toilet. So I've seen spreadsheets, data they've derived that they can actually show how the chemistry of the cesspools evolve depending on what's on TV. Like, it matters, right? Because people's diet shifts. So, the side effect of Sunday roast is different chemistry on Monday. And I, of course, I'm interested in everything. Like, it's hard for me to resist. So as soon as I was aware that I was talking to somebody who deals with this, I'm like, you need to tell me everything. Oh no, I want to see the spreadsheets. And I'm going to ask about some of these words because they seem organic. But yes, the goal is to make as dense a sludge as possible and release as much clean water as possible. And so they do this very precisely. And machine learning models are being introduced to that to be able to respond faster. And yeah, I thought it was brilliant, but not normal. Like very odd little part of our world.
Yeah, I have one presentation, The Age of Applied AI. And I always start with like 3 weird things I've seen, and that is definitely one of it. But what I always show is a AI-infused toilet. So it happens on the edge. Not like not like
edge analytics. That's the Japanese. They love that, right? That yes. Your toilet's evaluating you because you haven't had enough judgment in your life.
Yeah, and you get it on your mobile afterwards. Yeah.
But I mean, they argue that they can detect diabetes early, right? Because it shows up in the urine first. And so if you've got the sensors in the toilet, like you really could save a life.
Exactly.
You're starting to
Yeah.
see that with like the Apple Watch warning people of defibrillation and things like that. Like the software's gotten to a point now where the sensors we have can warn us of potential issues. I still don't want an IP address in my toilet, but that's just me.
Yeah, nobody should want that.
My toilet's offline. No, that's okay.
We don't flush today.
Yeah.
I pee in my toilet.
Yeah. 2 minutes for puns. Face the wall. Feel shame.
Thank you. Thank you.
What?
Don't
Oh, the camera is off again.
Good.
So it's overheating after this one.
That's fine.
But
I'll do my best
Same question
parts.
for you.
I love all of the weird and wonderful AI generated things. So I built a very terrible model once, which generated conference sessions. So we do a lot of this, right? And we go and we talk at events. And so I built a Python script to go and scrape events and scrape the abstracts that people submitted to attempt to, using a long short-term memory model, generate a new session that people would want to go and see. And it generated some okay ones, but during the demo, and I had it all up on the screen, it came up with a large expletive and then analysis services. And I was like, that's a session that I would like to see.
I can think of that expletive. Yeah.
Exactly. And so all of those things are really interesting. And this is a few years ago. And when you look at some of the large-scale language models now, and you look at what is possible with them, you can do some really interesting, incredible things. But generally, everybody makes really stupid things. And it's the stupid things that I think are the best, such as AI-generated Valentine's Day cards. That was a recommendation by Tori on our team, recommended to have a look at these. And they are incredible, just the most ridiculous things you'll ever read. And also things like AI-generated April Fool's jokes. So if you want to, do an April Fool, you can have a look at those. But the best part of all of those is they demonstrate how you go through building your own language model to achieve them. So yes, they're very stupid, but actually this is the practicalities of how you do it. So you can build your own stupid language model. And that stuff's great.
Now I know what to do at the weekend.
Exactly.
Side question. Did you submit any of the abstracts?
I was tempted. What you find with naive, like long short-term memory models is generally what they end up doing is just especially if you build this stuff from scratch, right? I think the general thing with any language model now is don't build them from scratch, like use transfer learning. If you build them from scratch, what you find is they overfit massively and they just generate the same things with minor changes. So no, I didn't submit any, as I think I'd just be stealing someone else's plus swear words. I did actually make a mistake when I was doing it. I was running through a demo as well, and I can't remember what that was. It was I took session abstracts, but one of the original demos was the entire works of Nietzsche. And what I'd accidentally done is also left those in. So I took a load of data conference sessions and the entire work of Nietzsche and accidentally trained a model which was half Nietzsche, half session abstracts. And, that's when you start getting some interesting stuff.
I can imagine that.
Das super SQL Server.
Yes. So about learning, because in this kind of field in AI every day, there is something new to play with. And it can keep you busy and don't get any work done. So a question for you. How do you choose what to learn and how?
That's a difficult question, yeah.
And how do you do that?
So I've got a long list of things that I like to learn and like to be better with.
So first up, you have a list.
I have a list.
And every time you write, if you see something new, you put it on the list.
Yes. The other tactic that I have, which is I probably wouldn't recommend it, is I join every Kaggle competition. And as the deadline approaches, I do that.
You actually do them?
I do them,
Oh,
yes,
so
I do,
cool.
yes, I do.
But you wait till you're close. Like
I-
you need the
yeah.
crisis.
Yes, I do, yeah. I need the pressure, I need the stress.
Okay, so what was the last one?
What did I submit last? It was the last one that I submitted was in May. Kaggle's got a new competition now where the competitions are set by community. So it's called every month they set a new competition. So I did the May competition. Was it May, April? So I submitted end of April at 11:45.
Oh my God.
So yeah, that's what I did. And I can't remember what it was. I do this every month. Yeah, it was a straightforward machine learning. Yes, I know that. Sorry, the last competition was Women in Data Science. It was a Stanford University run for climate change.
Oh,
So that was an interesting competition.
excellent. But if you have like new things, so that is one way of learning.
Yep.
But we were talking earlier about reinforcement learning.
Yeah, that's
that
part
is
of Kaggle
Kags.
as well. So
Yeah.
there's a competition on reinforcement
then-
learning. So, and I really want to learn reinforcement learning. And then Hugging Face sent me, coincidentally, a kind of schedule to learn about reinforcement learning, and I thought that will tie in really well.
That's good. So what is your preferred way of learning? Is that like buying a book in the or not, probably not from the library, that's mostly older, but order it from somewhere, or watching videos, or...
There's loads of resources nowadays online, isn't there? There's loads of YouTube channels, there's loads of blogs. So it's a bit of a mixture, really. I tend to use them all, and it depends what I'm doing. So if I'm doing a competition, then I'll tend to look at what resources are out there, whether there's videos to complement it. If it's a really specialized topic, then I'll tend to get a book and just read about it.
Thank you. Terry, for you the same.
How do I learn? I would love to say that I'm a really methodical learner like Gavi is, and I make lists. And I definitely not. I am definitely a good learner under a crisis. I would say like a lot of the stuff that I look at predominantly is about how to help people deploy things better. So I always focus more on the MLOps side rather than the machine learning side, and I leave that to smart people. And so from an MLOps perspective, I'm always kind of interested in, well, what are the current limitations and what's happening that will solve that? And so for me, that's a bit of, well, what's happening in terms of like the vendor space? What are Microsoft doing? What are other vendors doing? What interesting things? And that might be by attending their events. But the other aspect as well is more and more you see MLOps and kind of how to deploy sessions appearing at some of the larger machine learning conferences, such as NeurIPS and iClear and some of the other ones. So actually looking at the papers that people are writing as well is another way to definitely confuse yourself, but get a good understanding of what other people in academia are also thinking. And I always think that, a combination of the two certainly helps. Confuse you, certainly.
And kind of try it out for yourself. And
yeah, absolutely right. Try this stuff up, try it out, spin something up. And I always have the same example that I use for everything. So I'll take it and I'll try and deploy it in different ways, be that in a container, in Kubernetes, and something else. So I know at least I've got a constant that I can always evaluate different things with.
Cool. And what was kind of the last thing you learned in that space?
The last thing I learned. So I am always kind of continuing to look at kind of ways that you can apply things like fast API for machine learning. But one of them that went into public preview is some of the new bits around managed inference from Microsoft. And looking at that in conjunction with MLflow is a really interesting one, and said it's still an area that I am kind of actively researching as well. It's a great way, because it's one of those things like, should data scientists learn Kubernetes? And while I think Kubernetes is great, I think also asking data scientists to learn Kubernetes is a bit mean and a bit of a divergence from the skills that they should be focusing on.
I couldn't agree more on that. Richard, you have been learning since 1977.
I was learning before that too. I'm a good reader. I read fast. I live off of my Kindle. If you tell me about a book, I will inevitably buy it. And I travel a lot, at least I used to. I'm starting to again. And so my usual activity when I'm on a plane is to consume books. And I mean, the talk you just saw me do was derived largely from one of the most difficult books I've ever read, arguably. Because it was insanely dense. And I'm normally reading a book or two a week. That one was almost 8 days, which is a very long time for me. But I also make a lot of podcasts, and that means I get to talk to some incredibly smart people. And so that's become a channel for me of research. Now I have to plan them as well. So there's a meta conversation on top of that. One of the secrets of .NET Rocks is that I've had close working relationships with Microsoft for a really long time, and they normally share a lot of roadmaps with me. So I kind of know what's coming and what shows we need to make to help those things succeed. And then you get to go talk to the folks that are making it and have those conversations as well. It's not a normal way to approach things, but I've embraced the idea that I'm a professional storyteller, and then the challenge of that is being able to collect the stories and share them effectively. And then maybe my magic power is aggregating that data in the collective to tell at a different level. I don't invent as much stuff as some of those folks. Like, they're extraordinary in their focus, where I feel more like I've harnessed my ADD for the forces of good. Like, I like a lot of different things. I spent all day with Ryan talking about sewage and had a great time doing it and can tell you about it, but you didn't research it further after that. You move on to the next thing. Like, at some point it's just, oh, shiny, and off you go.
Exactly. So it's very interesting that you say, like, by forcing yourself to kind of do those podcasts, you meet other people, you kind of have to dive into those topics. Same as with you with Kaggle competitions, so you have like this driver. So Terry, I don't dare to ask, but is your podcast still alive?
Yes and no.
It's still alive.
So I didn't make it to 1,800 episodes, but the original one made it to 6. But we actually started a new one called Totally Skewed. And so original podcast you can still listen to, it's called Data Science in Production. And it's a great topic, but the scope is quite limited. So we flip things around. We started a new one every 2 weeks at the moment called Totally Skewed, which looks at data and AI. And that, touch wood, I don't see any wood, I'm going to run around and touch something in a minute. We will keep going. We're up to episode 6. We've got another one coming out, not this Friday, but next Friday. And so, yes, I'm back on it. And yeah, it's a great one, right? Just forcing you to research something and, as you say, try and tell a story that people will listen to. It's good fun.
Excellent. Yeah, I had the same thing because I have to explain like a lot of technology, Azure technology, and that is the time you dive into it, learn new things, and actually you're starting with Azure machine learning, you end up like researching PyTorch because you kind of needed like a framework to do something other than MNest demos.
And the great thing about coming to places like this is that you have to learn things so deep because we're expecting you all to have these horrible questions. And so you prepare for all these horrible questions and then people don't ask them. So you end up having to research stuff so deeply and understand it all that you end up being much better than you would have. And that's a great way to learn things much deeper, is to write about it and to come and talk about it at events.
I couldn't agree more on that. So we're going to close up because half an hour goes fast. So I'm going to have like one last question for all of you. So what is like the kind of most useful thing you have seen in the AI machine learning space at the moment that you're like, wow, that is super cool, that is super useful?
I would say so, not something that's super useful right now, but something that could be super useful very soon is a new approach to machine learning, which Google are talking about a lot at the moment, called pathways. And if you look at what a machine learning model does today, we have hundreds and thousands, millions, probably billions of machine learning models out there, and they all solve one problem and one problem only. But a lot of the models that we build generally share the same features, they share the same models, they're just doing a very singular task. And what Pathways is a different architecture which is designed to solve multiple different problems using the same data. So rather than having to spin up 15 different APIs to serve up different models, we train one model that can do a regression task for trying to work out how much somebody will spend. We'll understand when they'll churn. We'll understand what things we should recommend to them, all by taking different pathways through a different kind of neural network. And I think that although that's not something that we have today, it's a very interesting architecture that potentially has a great deal of impact further down the line and is something really interesting.
I'm going to add that to my list. Richard?
Oh, I mean, there's so many interesting machine learning things going on these days that are pretty profound. I'm fascinated by our approach to disrupting the phone, to getting into more augmented reality and VR spaces. I hesitate to say metaverse because, dang. But the idea that we're going to create models that allow us to operate in that space, that we're going to solve certain classes of problems that are best represented in 3D, I think is just a really new area in terms of dimensional science. So I keep my eye on that.
think for me, it is Hugging Face actually, how they are making it all, transformers so accessible to everyone really. It's so simple for us now just to grab a Hugging Face transformer and do wonders with it. So for me, I'm fascinated with that.
Perfect. Yes, I still have to add that to my list also. So I have a big list of what I'm going to learn up next. And I hope you also there on the stream you have some new ideas about what to learn next. So I want to thank you all for joining me today.
Thank you for having me.
And thank you for being live in London. It's been really cool to not have like the kind of Muppet Show kind of conversation with people again. So thank you. Thanks everyone for watching, and I hope you all have a great day.
This is my Muppet Show.
Oh, how long?
Just when you said when Gabby started speaking.
Oh, annoying. It gets overheated. To feel how hot. This is a new camera. It cost me more than 3,000 euros. And it just goes.
Overheating?
It's overheating.
Oh my.
So that's why I have this battery pack, but this
That was the A7, right?
Huh?
The Alpha 7.
Yeah. It's not a cheap thing.
No, I know.
No, and it is not like this rig doesn't really make it.
So you're feeding it like mains power? Yeah.
I can, but now I put it in a battery in, then it overheats less. This thing gets hot, it's Chinese, they don't want you to use it. So, that's awkward. Zolpek, are you joining for a beer?
Oh, for a beer and some food?
Yeah, I was thinking of going to the Hoxton Grill.
Yeah, I don't need like a lot of food, but just if I can get maybe a burger and some fries or something.
That's
like
there
that.
also, yeah.
You don't want to join for some food? No? You're gonna walk back? Ah, okay.
No, I'm not back, I'm going up to
Oh, right. I haven't decided if I'm walking or taking a cab.
I don't have it in YouTube anyway.
All the exercise I can get. And this is something you can control wirelessly?
Yeah.
That's pretty cool.
So it is on my mobile
Probably
phone.
very cheap, right?
You can't hook it up to an AI that will focus on the person speaking.
Yeah, but that's why I asked for an HDMI splitter.
Ah, right.
Because it goes into a Raven Eye, and then you click on the person you want to track, and then this thing just kind of tracks it, looking at through the lens of the.
Oh, the same as the drone.
Yep. It comes from.
We're going to run for a beer in is it the long arm around the corner?
Okay, yeah, I'm going to wrap up, and then I'm going to go to the Hoxton Grill, because I'm staying in the Hoxton.
Oh, okay.
Anyway, so if you wait 10 minutes for me to pack up, I will join. Otherwise, I'll come grab you there in the.
Just around the corner, long arm.
Okay.
It's
Yeah.
literally like we're there. It's you go right and then the left.
Okay, yeah. So the
We'll be having a
Hoxton,
beer
but
in there, pack up, come join us, and then.
if you already go to the Hoxton Grill, it's like there. It's
If we do Hoxton, really go and do Hoxton.
yeah. Then good.
Shall we take Richard already?
I think Richard will join. I just have to grab my camera and then I'm.
You pack.
Yeah, and I have to repack it anyway. And I'm staying at Hoxton Grill, so that's why I chose that place.
Okay.
Because then I can check in and ditch my bag.
So,
Very rare you use much time. You tend to make your thing, do your thing, forget about it.